Is there a watch somewhere that I can see how long I'm speaking? Because I don't have
A watch.
this watch.
Yeah. I think he has a timer. He can time you.
Well, I just it's good. This one. Well, I just put my cell phone up here.
Good morning, ladies and gentlemen, and welcome to the last day of our final colloquium for the young scholars. I would also like to take this opportunity to welcome our colleagues who are joining us via video live streaming. Today is going to be a half day, in fact. But we are going to start with an invited lecture by Professor Wolfgang Lutz, who is the director of the World Population Program at IASA. And immediately after the lecture, he will continue to chair the session for today. I'll still do the timing. So his lecture will start immediately at 9, and he's going to talk to us about world population trends and adaptive capacity to climate change. So for now, I'm going to give him the chance to set himself up, and then we'll start right away at 9. Wait for some other colleagues who are coming to join us. Thank you so much. Just to remind the presenters for today, the procedure will be the same as yesterday. Remember, you have 20 minutes for your talk. It's 15 minutes of presentation, 5 minutes of questioning. So after 10 minutes, I will turn on the yellow light, which means you'll be having 5 minutes to finish. So then I will turn on the red light. When I turn on the red light, you have to stop your presentation. Then it will be time for questions. Okay?
Okay, 2 more minutes, then I'm gonna start.
Okay, ladies and gentlemen, once more I want to welcome you all and our colleagues who are joining us via video streaming. We are now going to have a talk, 1 hour long talk by Professor Wolfgang Lutz, and he's going to talk to us about world population trends and adaptive capacity to climate change. Over to you, Professor.
Thank you very much. Good morning. I'm happy to be here in Bloemfontein and for this South Africa SA-YSSP program. Also, unfortunately, I'm only here for 2 days, but I have over the last 3 years closely followed what was going on. And since Gansen Pillai has yesterday already told you quite a bit about the YASA, about the setting there, the physical setting, the intellectual challenge that YASA faces in terms of approaching the very complex global issues in a systems analytical manner. So I will today focus more on one specific pillar of sustainable development. As you know, sustainable development is said to have 3 pillars: the social, the economic, and the environmental. And much work is usually done when you hear sustainability about the environmental implications, and this is natural because many of the previous studies in development did not give enough attention to environmental issues, and we do indeed face major challenges. And then, of course, is the continued challenge of economic development, of poverty eradication, and all these things associated with economic development. But there is a very important third social pillar that has to do with us, with the human beings, and that's what I'm addressing here. And I will start with sort of an advertisement of a major book we actually produced at YASA over the last 5 years. It is more than a 1,000-page volume published with Oxford University Press last fall. I have an executive summary here. It is only 60 pages, so it's easier to read. And I try to sort of summarize today some of the findings, but also put them into a bigger context, how sort of looking at population, human capital, social development in the 21st century interacts with economic and in particular environmental change. And this is sort of the second half of my topic. Another project that I carried out for the last 5 years is the issue of how can we assume today what will be the adaptive capacity of us, of future human beings, to environmental change. Okay, so I just go into the topic by sort of introducing, you may not all be familiar with demography is. It has two Greek words, demos, which is the population, it's the people, and graphein means to register, to write up. So demography essentially studies, registers, and also analyzes, models in a modern sense, population changes. And I may be able to show you a little today that actually these demographic changes, the changing size and composition of the population, are at the foundations of many social and economic changes and challenges that we face today. It's really us, the humans, who cause the problems and who also are the way forward. That need to come up with the solutions. And people, when they hear demography, they often only think of population size. And then in more sophisticated analysis, you bring in also the age structure and the gender dimension, so it's by age and sex. But there are many other important structures that distinguish us here in the room or the whole community here in Bloemfontein. The one that turns out to be very important and that I'm in a more formal way introduced today is the human capital side. It's education, also what is our skill, what is our cognitive ability, how do we understand the world and how do we behave in consequence. And then it's the changing health and disability structure. People of different health status also have different needs and different capabilities. Then particularly when it interfaces with the economic development, labor force participation, employment are very important, and there are also characteristics of individuals, whether a person is working or not. And then finally, place of residence or urbanization, whether you live in an urban area or in a rural area, makes a lot of difference for many things in your life and also for your impacts on economy and environment. So you probably are aware of, but maybe haven't seen such a dramatic picture yet, that where human beings exist for hundreds of thousands, millions years on this planet, depending where you put the starting point of Homo sapiens. For most of human history, there has been very few of us. Actually, several times during human history, our species was threatened by extinction. There were just maybe a few 10,000 people left. And as you see from this graph, it was really until about 1800 that the world population clearly was below 1 billion people. That is less than the population of Africa is today. And then something happened. It started first in Europe in the second half of the 19th century. That population started to increase, not because they had more births. They always had a high birth rate, but the high birth rate was always checked by a very high death rate, particularly infant mortality. So what happened is due to better nutrition and also basic sanitary measures such as clean water supply, the beginning of sewerage systems, very trivial things like people starting to wash their hands with soap had an immediate impact on mortality, on the death rate. And since an equal number of babies were born, but fewer people died, that meant population growth. And that is sort of this phenomenal increase that then after World War II in the 1950s really spread all over the world. This was also the introduction of antibiotics, as you may know, and that really also a consequence of the war when there was military action movement all over the world. These medical advances, both in preventive and curative medicine, spread rapidly and fell to a precipitous decline in death rates in many countries of the world, where at the same time fertility rates, birth rates were still high. Why were they high? Because throughout centuries, societies had developed norms, religious norms, cultural norms that always favored high birth rates, because otherwise the society was threatened by extinction. So this is very much embedded in our norms, and norms change more slowly. Whereas if we have a chance to avoid the death of our child, we grab that chance immediately. So this discrepancy opened up, so to say, the death and birth rates, and this is resulted in very high population growth, what some people call the population explosion or even the population bomb, just this unprecedented growth, where we are now somewhat above 7, maybe 7.2 to 7.3 billion people. Nobody has a very precise number of the world population. We only have a rough number. And then these different colors for the 21st century, you see, that is sort of an uncertainty range. That particular one is based on probabilistic population projections that we produced over the last 15 years at YASA. And all of 3 different rounds of projections, but essentially what they show you here is there's huge uncertainty. So this brown, the whole trumpet, so to say, gives you the 95% uncertainty range. The line in the center is the median, where half of the simulated cases are below and above. That is already an assessment that was the last that we had published in Nature in 2008. We now, this new assessment, like many other new population projections, put it generally a little higher because the fertility decline in Africa did not proceed as rapidly as many people had expected a decade ago. So we'll talk about this a little later. But generally, you see there is significant uncertainty that by the end of the century, the world population could be less than today, or it could be more than 12 billion. And where exactly it will come to lie in between is a matter of discussion. And here you see sub-Saharan Africa, where there's no uncertainty, that there's just no chance in the world that population would decline in Africa over the course of the century for 2 reasons. The one is that birth rates, fertility rates are still so high, 5, 6 children average per woman, that they just can't fall overnight to a level of 2 replacement level fertility. So it takes some time. And the second reason is that there's a very, very young age structure And that is what we call the momentum of population growth. If there are many, many children, they are the future mothers and fathers. So as they move up the age pyramid, so we know for sure that there will be more future potential mothers and fathers than today, and that is also a factor, an age structure factor contributing to further population increase. So doubling of the population in sub-Saharan Africa is very likely, and depending on how fast the fertility declines, it could even be a tripling, or some people even envision a quadrupling of the African population, with all the consequences that will have for social development, economic development, and particularly environmental impacts and the feedback. Of course, these people have impact on the environment, and the environmental change impacts their livelihoods, their health, and their wealth, and we'll talk more about this. But you may also know that there are other parts of the world where the population is already in decline. This is Eastern Europe. Eastern Europe is already a relatively old population, in the sense that the age structure of the population is rather old, like in Western Europe. But in addition, the fertility rates have declined dramatically after the political change in 1990. Birth rates have been much lower now, and in addition, we see quite some outmigration. So Russia is sort of a special case because several ethnic Russians came in from other Soviet republics into Russia. But if you look at the other former republics, the more Western former Soviet republics, as well as the countries in Eastern Europe that have now joined the European Union, there has been quite significant outmigration. Bulgaria, for instance, is really shrinking very rapidly. I mean, I've recently been an advisor to the Prime Minister of Bulgaria, where they are sort of really under shock that the population has already declined by some 20–25%, and it may halve over the foreseeable future because of this combination of very low birth rates, high outmigration, and actually not so good life expectancy, which is also moderately low. So all these three demographic factors come together to result in shrinking. Now, what is the global systems analytical approach? I tried to indicate already that these population trends, how many of us there are and how our structure changes, are not happening in empty space, but we need food, we need health services to some degree, and impact on the environment in many respects. So this 5-year project that I had funded by the European Research Council on this forecasting society's adaptive capacity to climate change, tried to look on what I call the feedback in this loop. So here we sort of zoom into the human population, as it may be structured. We talk later about age, sex, level of education, place of residence, or maybe household structure. And then, of course, if many of you have now talked in your presentations, and many studies exist, we humans, mostly through our consumption of energy, raw materials, whatever, impact on the climate system, mostly through greenhouse gas emissions. So that is sort of a direct influence of human behavior on climate change. But also climate change mitigation, so the reduction of our impact on the climate, the reduction of greenhouse gas emissions, needs to start from us, the human population. So that's why sometimes people study how here you have the human population, which is sort of a liability, how many mouths we feed, and then there's the human actors who need to do something good to mitigate climate change. Well, we are the same people. It's the same people who are consuming and having a negative impact, and us also need to come up with the behavioral change and also with the technological innovation. And there's, at the moment, all this speaking about green technologies, green growth, really puts a lot of hope here on the innovation side that will help us to somehow maintain our standard of living, not having to significant declines, but have a much lower impact on the climate. So I'm just mentioning this because there's been lots and lots of research on this. But very little is known about this other curve. How would climate change, as it is predicted by the global circulation models, on future human well-being? And it's sometimes even disappointing to see how very good scientific studies who are very detailed on this side then are very speculative on the other side. They say, well, this will be a terrible tragedy, a catastrophe of human population. Human civilization may go over the cliff, or whatever rather unspecific threats being mentioned. And I think we must be much more specific and must get a better analytical handle on what people are more vulnerable than others. In their livelihood, there may be direct effects on health and mortality, but also changes in livelihood may trigger migration. There has been a lot of writing of environmental change-induced migration, and the fact is that we know very little, and UK Government Office of Science has recently issued a major foresight study in which I was involved as a review, scientific reviewer there, where they were quite critical with this panic notion that there will be just mass migration induced by climate change, because the evidence so far at least is that most people who are displaced because of some natural disasters or flooding and so, they try to stay as close as possible to where they are from, so that it's internal migration, it's small area change of residence. But that's another topic. I just wanted to mention that migration is also there. Now let's step back a bit, since we are talking about systems analysis. This is really the mother of all system models. Does anybody recognize this, what it is? It is a time when there were just mainframe computers with big printers. It's called World 3. Does this ring a bell? Well, that's the famous Club of Rome study, The Limits to Growth, in 1972, which was really a approach. And it was a model of the world with some fundamental variables included and some assumed interdependencies between these. And this is sort of the basic run, 15 and 2020. In this model, you see that the food supply collapses, induced in part by this non-renewable resource decline and the rapid increase in persistent pollution. So at that point, there are formulas, there are functional relationship that they calculate results in a rapid increase of the death rate, you see, even higher than it was in pre-modern time. This is the reason through education. And I had the opportunity a few years ago to be on a seminar in New York with Eric Kandel. He's born from Austria, a Jew who was then driven out, and professor in Columbia in brain research. And in the year 2000, he got the Nobel Prize in medicine and physiology for his work on memory. So his famous book, In Search of Memory, which is a nice blend of his personal childhood memories in Vienna and then in the US, and also what we know about how memory functions in our brains. And he frequently sort of finishes his seminars with saying, now let's repeat this point for a third time. And that's how a brain functions. If you hear something once, it's stored temporarily, but after a third time, it tends to be stored permanently. They're just the real new synaptic structures. And he says, now once you walk out through this door, you are physiologically a different person than when you came in. So learning makes us different. And I think there's also no doubt in experimental psychology or whatever that the enhancement of cognitive skills changes our behavior. It typically makes us less risky in our behavior. It extends our personal planning horizon. It's easier for us to learn from past damage. So if you make one bad experience, it just very clearly shows that the more educated are capable to more quickly learn from this and avoid this behavior, whereas others have not a steep learning curve, and they probably sort of burn their fingers several times before they take action. And then very clearly, also the more educated have better access to relevant information. And then there are these indirect effects. They also have positive implications of improvement of health and physical well-being and higher income at the individual and household level. So this is just to show you that education is not just an attribute that somehow society assigns to people, so it's something that really changes us physiologically. It's some occasion even said that people think that age and sex, these are sort of truly natural physiological characteristics. Well, that's not really the case anymore. Some of our work, for instance, is redefining age. We say 70 is now the new 60, so age has not really any. It means in the times of increasing life expectancy and better health, age has not the same meaning. And also, all this debate about transgender, and in some countries even people are not forced anymore to say whether they are male or female. And this is also, neither age nor sex are what they used to be in terms of clear physiological definitions. And we now understand also that education does have some physiological components in addition to components of social construction. So how do we measure human capital? It's not an easy field, and there has been a lot of work in this. Generally, it makes sense to distinguish between formal education and informal education. Formal education is essentially what you learn in school, and informal education is everything else. But formal education is, of course, much easier to study because there are statistics about it. But even if we only focus on formal education, there's really the quantity, how much, how many years. Then there's the quality. Do you get any good education or bad? Is the teacher actually present in school? How big is the class? And how well is the pedagogics? And then it's the content. Well, content in particular makes a difference at the higher levels when you either go into the humanities or more into the natural sciences. And at the basic level, it's sort of reading and writing and counting skills. But still, the relatively early on content starts to matter. Now, again, many people are mistaken. They think when they talk about education and even human capital, they think of schooling. Well, probably helps to think in terms of education flows and stocks. So schooling is the flow. That's the policy variable that we can introduce. How many people do we get put into school? But being in school by itself doesn't have any positive aspects for society. These come when people leave school and when they have higher skills, when they've changed their behavior. And that's what the education stocks. And the education stocks, they change very slowly, and they have a great momentum. And we can measure the education stocks in different ways. Economists usually have the mean years of schooling of the adult population above age 25. Or we can have the full distribution of highest educational attainment levels by age and sex. Or we can actually test that by in functional literacy. Now, one way to show the age and sex distribution is these age pyramids. I'm sure you all have seen age pyramids. You have women to the right and men to the left. And then you have the age here, and you see how many there are, how many men and women there are in each age. And what we've done is simply added color to this. So red means the person, in this case more women than men, had never been to school. And then orange, primary education, light blue, at least completed junior secondary, so up to age 15, and dark blue, at least some completed post-secondary education. Now, this is a country that I visited first in 1985, and Singapore. And what me really sort of struck there is I really met two different Singapores. They were the young people they talked excellent English, they were using computers, they were cosmopolitan, and they were not so much different than people in Europe that I knew. But then when you went around the corner, there were poor elderly people who only talked Chinese and who went to different restaurants, and it was just a completely separated society into two classes. Well, sociologists often talk about classes in society, but that's a very particular, because here the difference is not different sectors of society, but it's different age groups. We had the young ones being much better educated, and the old ones still being born at times when they have the right to go to school or the possibility. So it's really an inter-cohort rather than an inter-class difference. So we, for all countries in the world, reconstructed back to 1970 this destruction. And Singapore, like other phenomenally performing countries, South Korea in East Asia, were desperately poor and 80% uneducated around the 1950s. And then the government really massively started to invest in education. And you see by 1970, among the young ones, most of them had already gotten some kind of education. Even half had secondary education. But look at the older ones. Women above the age of 45, almost all of them were illiterate. They've never been to school. So this I call demographic metabolism. It is how societies change, not all ages at once, not all cohorts, but typically from the bottom. Schooling happens and many other things happen at young ages and then are sticky. People maintain this characteristic throughout their life. And that you see how now the society of Singapore will change simply as a function of the better educated young cohorts entering and the less educated older dying. So this is 1980, 1990. Now you see really the young ones have a high degree of tertiary education. And this, by the way, was the time when Singapore had this phenomenally high economic growth that made it one of the richest countries in the world today. And this was precisely when these better educated young cohorts in their mid-30s entered the business, they entered politics, they entered society and made a major difference. But still at the time, the uneducated elderly were there. So only slowly they've been growing out and dying. Now 2010, this is today. Now Singapore has already one of the highest proportions of young people with post-secondary education, almost 80%. Singapore and Korea are world leaders in this respect. But look at the elderly, still there. You think it's one of the best educated populations in the world. Still women above the age of 65 are largely uneducated. And this explains really, once you put in this age dimension of education, you can get a much better handle on explaining how human capital also improves economic growth and many other things that we like to see. Here, okay, we can also make projections of this. 2030, and then Singapore has very, very low fertility, so the age pyramid gets narrow at the bottom. And the key question is whether these much better educated young people in economic terms can compensate their lower numbers through higher productivity. Okay, now we switch gears and go back to Africa and to the future in the poorer countries. And you see that in every country of the world, but particularly in the poor countries, always infant mortality, what you see here, under 5 mortality, is much higher for women without education, for mothers without education, these are the red bars, than for those with primary or secondary education. You have this very clear gradient. The same is true with respect to the fertility rate. Let's just look at Ethiopia in 2005 there. There you had, if women were completely uneducated or mostly illiterate, her average family size is 6. If she has some secondary or higher education, it meant at least to age 15, 16 to school, her family size was 2, a major difference. Now, whenever I talk this to economists, they say, well, it's not really education that makes the difference, it's income that makes the difference. So we did a series of studies where we showed what matters more, mother's education or household income. And what I'm just showing you here is a very simple 2 times 2 matrix that already hints where so we group on the one hand women who have an education that is below the median or above the median, and here people who have a household income who are below or above the median. And of course, most people are here in the low educated poor or here in the more highly educated rich. But there are some off-diagonal people. There are some who are relatively low educated but somewhat richer, and the other relatively better educated but somewhat poorer. And comparing these two is quite illustrative, because in every country that we looked here, infant mortality, and whatever indicator you take, the more educated but poorer are doing better than the uneducated richer. So that's the first indication, but we've done many very complex multi-level statistical models that clearly confirm that for infant mortality, mother's education is more important. And I just showed this for different countries, Indonesia, here in Malawi. Just the level overall is higher, but again, you very clearly see that these women are doing better than these women. Now, just a word on population projections that I'm going to show you now for the rest of my time. Let's see. Yeah, we still have some time. Population projections for many countries in the world. So we have fertility, mortality, and migration. Populations can only change through these forces. So what you do, let's say you have a population pyramid here in the year 2000, want to project it to 2005, you just shift it all by one step, 1 5-year age group up. And then, of course, at the bottom you are empty, and that is filled with the babies born. So you apply a set of age-specific fertility rates. I'm sorry, this has sort of moved a bit too far up. So it's applied to the women from 15 to sort of 45. And that is then these babies born by those women are then making up the new age group 0 to 4, of course also made subject to infant mortality. Then at every age, of course, people are dying between 2000 and 2005, so you have sets of age-specific mortality rates. And then you have migration, people coming in and out of the country with different ages. So when you have some assumptions about these three forces, then you can do population projections. Now, how does this work when we add education? Well, it just gets by one dimension richer. So here you have this education age pyramid that I saw them before, and we then have just women with different education levels, have different age-specific fertility schedules that result in these babies, and then we have different mortality schedules depending by the level of education, and we have different migration schedules. So it becomes sort of a three-dimensional instead of a two-dimensional thing. And now when for this book, we had to sort of make assumptions of how the education-specific fertility rates evolve for all countries in the world. Let me give the example here of Kenya. So we had in the starting year, this is empirical data, uneducated women had more than 6 children, whereas women with some post-secondary education had already less than 2.5, and those with upper secondary had 3. And then we sort of have, following the experience of the other countries that have already lower fertility, a convergence, whereby the relative differences, they're almost constant, but of course the absolute differences at the overall level declines and diminish. And then you see here the combination, and this is under the global education trend scenario, where sort of moderate education improvement is. And it's interesting that you see that the aggregate total fertility rate is not parallel to these lines, but it declines somewhat steeper. Why? Well, because the overall educational improvement is taking place, and sort of the weight of these high education, low fertility groups is increasing over time, and that's why this aggregate line is pulled down to the more low fertility groups. So these sort of things we had for all countries in the world, and we summarized this whole methodology and the approach in a recent review article entitled Global Human Capital, Integrating Education and Population. And there we show some calculations for the world as a whole. So assuming identical education-specific fertility trends, as I said, as I showed you now for Kenya, so we have this identical set. Depending on which education scenario we use, there can be 1 billion people more in the world or less by 2050. So this is the most pessimistic education scenario. Constant enrollment numbers, essentially no additional schools being built. The number of school students is constant, but the population increases, of course. And there you see that over time, the educational composition does not improve. Quite the opposite, the number of the red area is increasing here, and the population is rapidly increasing, reaching already 10 billion by the year 2050. If we have the fast-track education scenario that essentially assumes that countries would embark on a trajectory such as Singapore or Korea, then of course we'll have much better educated people. There still are going to be a few uneducated women because they are older. As I said, you can only change from the young ages. But already these changes over the time horizon to 2050 cause, assuming identical fertility rates, 1 billion difference in world population. Now, I don't have much time to now go into this new scenario analysis. I just want to mention to you that YASA has been developing the old IPCC, Intergovernmental Panel of Climate Change Scenarios, and that were relatively parsimonious on the social side. They only had total population and GDP as the only social and economic indicators. And now a new generation has been internationally developed, the so-called shared socioeconomic pathways, SSPs, and they are there to jointly address the socioeconomic challenges of climate change mitigation and adaptation. And here the population, what I call the human core, is stratified by age, sex, and education. It's these colored pyramids that I just showed you. So this is the basic idea that societies face both challenges for adaptation, but also challenges for mitigation. And then we have sort of 5 scenarios here. I'm going to say a little more about this. So this is the middle of the road, the SSP2 scenario that you can also call the medium, or if you want, most likely population projection. That's the outcome of an exercise that involved more than 560 experts from around the world with online questionnaires and meetings on 5 continents and so on. Now what you see here is that the world population is increasing until the second half of the century, and then will be leveling up and reaching a peak somewhere around 2070 possibly, of roughly 9.4 billion, and then start to decline. But more dramatic than this really is the change in the educational composition with this massive increase of people with secondary and tertiary education. Now, this is not so for all scenarios. It's even better in a way under the SSP1, which is the rapid development, or sometimes called the sustainability scenario, where actually we don't just continue the education trends, but we have a speeding up, not quite a fast track. That would be unrealistic for all countries doing this, what Singapore did, but somewhere in between the business as usual expansion and the fast track. So you see that indeed the population is peaking earlier, already by the middle of the century, and by the end we really have a much, much better educated world population. And the SSP3, that's the stalled development, where we have essentially the constant enrollment, and fertility declines only very slowly, and also mortality declines only very slowly. And here we do have very significant continued population growth up to 12 billion people. You may have seen also the UN came up with a new population projection. It was published in Science last summer. That is somewhere between our medium and this SSP3. And one of the main differences is indeed that they do not take education explicitly into account. And once you do education, to take this relationship between female education and education into account, you get a lower population future because there is very likely to be a better educated female population around the corner, so to say, because this is already embedded. So this is sort of the world population as we have it today now, an age pyramid. You see, this was 2010, was 6.9 billion. Now we are more sort of 7.2 already. You still have in red the uneducated, which pretty much is the same what the Paul Collier calls the bottom billion, the poorest of the poor. And then you see, but almost the majority, so more than half of the world population, has some sort of secondary education, and then the tertiary is, of course, more prevalent at the young age. Now, this is the SSP1, where you see that at the global level, actually the age pyramid, because of rapid fertility decline, will narrow at the bottom, and it will be a much better educated, almost looking like some of the, not the highest European developed, but some intermediate developed countries in Europe. And then we have the SSP3, this is the stalled development, much bigger world population, and still looking like a pyramid, many more young people, and actually see an increasing number of people without education here at the bottom. So this is not a good scenario. India, some people yesterday said about what about the gender dimension. The nice thing here is we really very clearly can identify gender discrimination, which in India is quite pronounced. You see the group of uneducated women is almost twice as high as that of uneducated men in all age groups. And even the Indian government is now really making efforts for universal education, but they can't change the total composition overnight because of this momentum of demographic metabolism. So in 2030, as we see here, there can only be some improvement at the bottom, but for the population above age 50, not much can change. Okay, now let's go to South Africa quickly because time is running. So this is the education pyramid for South Africa. It still looks like a pyramid up to the age of 25, and then fertility decline came in, and then it's sort of pretty rectangular for the bottom, and you still see clearly, like in most of the other countries, that you have still a concentration of completely uneducated more among the elderly, and here you have an expansion, but this expansion has been mostly at the primary and junior secondary level. Now, what is the future? Well, population will get older, and we have in South Africa a huge difference between male mortality, which is much higher, and you see that there will be many more elderly women than elderly men. That's in every country, but in South Africa, this is particularly pronounced in part because of AIDS mortality, but also other reasons. And yeah, this is 2060. Well, but this is sort of one scenario only, a scenario of only moderate education expansion. If you, of course, it can vary depending on your education scenario. As I said before, like the big picture for South Africa, you see that in 1970, South Africa still had a very high proportion of uneducated people. So this gray area is the children below the age of 15, and then and almost 1/3 of the population had no formal education, and then you had just some primary, and the highly educated was really a narrow elite. This, of course, was the apartheid time, and then population increased very rapidly because fertility rates were still very high. Well, that's where we stand today, and this is sort of the global education trend, sort of the middle of the road scenario. This would be the constant enrollment rates scenario where population would be higher and actually very, very thin educated elite. And this would be the fast track, like following with a major effort, the South African education system would follow that of Korea or Singapore. I'm not sure how realistic, but at least we calculated what would be the consequences. Nigeria, to mention, is a country that has really extremely rapid population growth, still very high fertility, somewhere around 6. But again, here we just don't know what the education future will be, and it depends how the civil war continues in the north of the country and what the political conditions will be. But in principle, even if for the fast track scenario, because of this very high level of fertility at a very young age, distribution of the population, significant population growth will be expected. Now, what does this all mean for economic development? We recently had an assessment in science there where we took all these reconstructions, I've showed them by age-specific education distributions, and could finally very well establish what previous economists were always wondering. Theory told them that human capital should be good for economic growth. But in their data, they found very mixed results. And the reason was that they took only a very crude measure, namely the mean years of schooling of the entire adult population, which mixes for every country this uneducated elderly with the often highly educated young. So if you split that by age cohort and more precisely see which group comes into the main working ages, then we get a much clearer statistical signal that very clearly and statistically significantly establishes this positive effect of education on economic growth. And if you look in the upper right corner, one of the interesting findings was that complementing primary education with secondary education in broad segments of the population is likely to give a strong boost to economic growth. So it's not investing in elitist education and leaving the rest behind, but it's really the universal secondary education that makes the difference. And talking about policy impact, I mean, as you know, there are the new sustainable development goals now being defined. And of course, there are many different pressure groups and argumentations behind the definition of these. And it cannot be assessed what are the reasons for certain goals. But it's fair to say that this analysis of EDIASA is the only sort of quantitative global time series analysis that clearly makes this point, and therefore we were very happy to see that the new goals, as you know, the Millennium Development Goals only talked about universal primary, and now the Sustainable Development Goals are likely to settle for universal primary and secondary education for all girls and boys. Now time is running, and I'm 10 more minutes. Want to enter now this field of what does education mean for vulnerability to natural disasters. This is a good example for systems analysis again, because many people thought, are you crazy? I mean, education, that's a sort of social development business, but here we are dealing with hurricanes and storms and people being hit and killed. What does education have to do with it? Maybe whether they have strong houses, and then income was put in. And for that reason, many of the disaster vulnerability surveys that we saw, they didn't even bother to ask what was the education of the people. They had very detailed information about the construction of the house and other things. But as soon as we actually paid some people to go back to their sample and collect the additional information about education, And surprise, surprise, education turned out to be the most important protective variable in natural disasters. So what are the mechanisms? Why can education play a role here? Well, we talk pre-disaster. More educated people have a better risk awareness and understanding. Then there's typically, and this is confirmed by several surveys, better disaster preparedness. They are more aware of what can happen and take active steps to be prepared. And they choose, if there is serious risks, they rather choose to live in low-risk areas. And then during the disaster, of course, it depends. Some disasters doesn't discriminate at all who is it. It just kills everybody who is there. But still, more educated people are doing better in understanding of warning messages, also being more efficient when it comes to evacuation and so. So even during the disaster, it often has a significant effect. And maybe one of the strongest comes then after disaster, the impacts. That being able to absorb the shocks, recover from morbidity or the mortality of family members or the damages to houses. They more easily find a new job. And even at a psychological level, they more easily overcome post-traumatic stress. This has all been studied with respect to the Asian tsunami and several of these issues. And actually in this special issue here, we have 11 studies that focus in very specific cases as well as in international comparative analysis on this issue. And I just wanted to show you one analysis. This is sort of a global level for countries with more than 30 disasters, where you here have the female education, or the proportion of women aged 20 to 39 with secondary or higher education. That's a sort of a very critical variable. And here the logarithm of the death. And you see a very clear association. And one of the papers in this study looked at the three countries in the Caribbean that are very close to each other, Haiti and the Dominican Republic on the island of Hispaniola and Cuba right next to it, that are hit by exactly the same hurricane. So it's the same strength on the same path that goes over these countries. Well, what happens in that poor but well-educated Cuba, very few people die, if at all. There are a few injured, they are very well prepared, and there are very well evacuation plans and everything. Dominican Republic is doing quite well economically and has sort of an intermediate education, and you see they are sort of doing it in an intermediate way. But when the storm then comes to Haiti, it's just disaster. This is the log scale, you must remember. So Haiti has just many, many more deaths, and they are neither prepared, nor can they well evacuate, nor do they recover well. And this, of course, Haiti is both very uneducated and very poor. So particularly the role of Cuba really shows you how even being poor but well educated and well organized can make you much less vulnerable. And actually the whole thing we managed now just in November, a couple of months ago, have another piece in Science with this headline, Universal education is key to enhance climate adaptation. And you can believe it was not easy to get it through the refereeing, because all the engineers and all the people with climate adaptation, what the hell do you know about education? What does this have to do? For me, that's a good example of systems analysis, that you take some factors that are typically considered to be in a different sector and see what matters for another sector. And in particular, subtitle that we didn't put, but Science Magazine put in there, didn't make some people happy, that fund more educators rather than just engineers. Because you know there is this major green climate fund now where the countries have pledged for 20 billion to be raised by 2020. And we looked what happens with the money that's already on the table. It almost 100% goes to engineers, seawalls, other protection systems, and so on. Okay, well, these are just some of the outcomes where we see how this different. We apply the different SSPs to the disaster death, and with different, you see the three different blue lines are different increases of the hazard, so more or less strong climate change. And you see the blue are based on the SSP3, and of course, if the hazard increases very strongly, you have a very significant increase in disaster death. And under the SSP1, which is the rapid development, you have much less. So the vulnerability and the number of projected deaths is, of course, much, much lower under the high education SSP1. Okay, let me conclude by pointing out that sort of that we focus on the human resource base of sustainable development. That is sort of what the main point is that we try to bring across here. Human resources, what do I mean by this? Human resources refer to the ability of people to help themselves and help others. And they crucially depend on age. Of course, a baby cannot help others very much, but needs help quite on the health status, on education, but also on, such as motivation and social networks, etc. And education is really, as we showed, one of the most central drivers of this. And it's not just what happens in school, but really learning from the first day. Early childhood education is extremely important, as is lifelong learning and continued education. But formal education, schooling is easily measured, and therefore for the statistical analysis we used it, and it showed these very interesting results. Well, there's also a discussion going on that there is, Cairo plus 20. Cairo was the World Population Conference in '94, and we just had the reassessment, a big UN process. And I published a paper before with the title, the 21st Century Population Policy Paradigm, not just focusing at the number of people and the age structure, but really at the human resource in a broader sense, which is a nice policy because it is valid for all countries, for the poor as well as the rich ones, because better education also helps you better to cope with population aging. It is fully consistent with human rights, which many of the old population policies that try to coercively bring down fertility were not. And also education and health are really at the heart of the MDGs and the SDGs. And in particular, the interesting thing is that the focus on female education should get priority because it empowers women within the family and society to exercise their reproductive rights. The more educated women want fewer children and have fewer children, and they find better ways to actually have fewer children, even if their husband wants them to have a bigger family size. That's quite frequent in Africa, that the men want to show off with a big family, also they don't have to look after the children, and the woman who has to do the work, she would be interested in having fewer children. So it would moderate rapid population growth. It would contribute to poverty eradication and economic growth. It helps to increase female labor force participation and productivity. This has been shown in many countries. For instance, in a case study on the island of Mauritius, where female education really was the key for this stunning economic success story of Mauritius. And also contribute to the quality of institutions and democracy. I don't have the time to go into this, but we also have some papers on this. Let me conclude with just a look at the world as it was in 1970. So here you see the proportion of women. I'm sorry that it happens to be the German version. There are 20 to 39 who have at least secondary education. And here you have the picture that many people still have in their mind. It's the red areas, this global south, the developing countries, and then the OECD and developed countries doing well. Well, this has changed, fortunately, quite significantly. China has become dark green. Even some African countries, almost all of Latin America has become green in that sense of having, more than 60% of the young women already with some secondary education. And this trend, as I showed, will continue in the future, and there will just be a few pockets, I don't know, in Somalia or so, but this depends on country-specific trends in the future. But we are on an upward trajectory because in almost every country, the young women are better educated than the older ones, and this means that the future old ones will also be better
Excuse me,
educated.
sorry, what does white represent?
Sorry?
White.
White, no data. No
Okay.
data, yeah, okay. Okay, that's just a very final thought. As you know, sustainability is usually said to have three pillars. As I said at the beginning, the environmental, the social, and the economic. And through these three pillars, we need three types of resources. Of course, we need the natural resources, who are the basis for human life, all services, natural services to support the human life. Then we do need economic resources, financial resources, infrastructure resources, but we also do need the human resources for sustainable development. And we should not forget about them. Humans are not just the mouth to be fed, or the people to be worried about, but also the people who are going to bring the change about, who are the actors of this change. And with this, again, somewhat positive, this was the world. Now I show the age distribution, world age pyramid in 1970. You see a lot of uneducated red people. Here we are today, still the uneducated bottom billion, a much bigger population, but a much better educated. And this is the medium scenario for 2050. Again, a much bigger world population, but we know quite sure that in many countries there will be more educated than today, and that's a moderately optimistic view into the future. Thank you for your attention. I assume there will be many questions to so many points, but maybe you're already tired from listening.
Can take three questions from the floor. Yes, sir.
Wolfgang, thank you very, very much. It was a fantastic talk, like usual. I just wanted to ask, to what extent in the disasters or the impact side do you include things, the sudden shocks that have come up in health, for example, Ebola, and how they might link to climate risks, and how does that build in? Can you build in shocks like those kinds of health outbreaks?
Well, there are sort of two sides to this. The one is in a pure sort of demographic modeling, what we assume in terms of future mortality. And yes, there, sort of the three main scenarios is either sort of intermediate, rapid, or slow increase in life expectancy. But that, of course, does not include any of the maybe low probability but high impact mortality crises. And for that, we have done a set of special scenarios where we see. The problem is that it's really relatively arbitrary because we don't know where, when, and to what extent such a crisis will hit. And we just say, like, if there is something terrible happening, let's say in Western Africa, killing 20% of the population, what does this, and then sort of this going to be over after 10 years and people recover, what would be the demographic impact? And of course that you see somehow in the age distribution. And so we experiment, but of course there are a limitless number of possible disasters that you can model. So we just gave this sort of a model, but in the mortality chapter there is a section on this. The other interesting thing, also when it links to education, is sort of what is the role of education for these sudden impact things. And there's an interesting thing that for many crises, take for instance the AIDS crisis, or smoking, if you want to call it a public health crisis. At the beginning, it was actually the more educated, they were more vulnerable because they were more mobile, and they didn't know yet that smoking was dangerous or how AIDS was transmitted. But as soon as the mechanisms became clear, it was the more educated that then changed their behavior more rapidly. And that's why AIDS these days now is essentially a disease of poorer, less educated people. And the same with smoking, you see. So there is, it's not always a one-to-one. In some cases, indeed, the more educated, because they are more the pioneers, they're more forefront with any kind of new behavior, may also be more easily hit by some dangers. But they have a steeper learning curve.
Thanks, Wolfgang. I'd like to ask you, I thought those data on education levels in developing countries and disasters was very interesting. Could you tell me, is there a relative balance between the level of education and people's ability to prepare versus people's ability to respond?
My colleague Raya Mutarak, who is also one of the supervisors here, that's her specific field of study. She's carried out quite some surveys in Thailand on both of these aspects. And as far as I know from her studies, there are impacts on both sides. And again, it is, let's say that preparing, there was an interesting question, you know, that the Phang Nga Phuket region was hit in 2004 by the major tsunami. And then she asked people there in the region, in the survey, whether people had experienced the tsunami or they had migrated to the Phang Nga region later because there's a big migration because of tourism. And then for the educated people, it didn't make any difference in their degree of preparedness, whether they had experienced the tsunami or not. They were quite well prepared. But for the less educated people, there was a big difference. If they had experienced the tsunami, they were much better prepared because they knew what it would be. Whereas those who came after the tsunami, they were worse prepared because they had problems thinking the counterfactual, what a tsunami would be and how dangerous it would be and how dangerous it would happen. So in that kind of preparedness, education and a more abstract counterfactual thinking actually helps you to be better prepared.
Okay, can we thank Professor Wolfgang again?
Now I take over your
Yes,
microphone.
please.
Okay, sort of uninterrupted action this morning. Good, so the next speaker will be Annette Alemann. Is she here? Yes. And the topic is mathematically modeling a research question: is the ultimate yield of soybeans affected by the effect of the RR gene or root exudance? Please, the floor is yours. Can you deal with?
Yes, just mine should be lying here.
Is it open to Alemann?
There it is. Good morning, ladies and gentlemen. Here I stand in front of you again, luckily for you, for the last time. My title, as you see, has changed again. This is not from fickleness, but this is the development of the work we had been doing. And today I'm going to ask the question of whether the symbionts being in the plant avert root diseases in soybeans. As I said the very first time, most countries, most populations, their staple foods are very high in starch and very low in protein. Protein which is absolutely essential for the development of happy and healthy children. Breeding animals for protein is very expensive and often not possible. Growing plants for protein can be very expensive when it comes to nitrogen fertilizers, which are also pollutants before and after usage. Now, luckily for us, soybeans are legumes. And legumes have this absolutely fantastical relationship with bacteria. Now, most people hear bacteria and they think, germs! Now, I also thought, germs, till I met them. There are many more beneficial microorganisms than there are bad or unhealthy ones. I'm a great fan of beneficial microorganisms. Anaerobia is a very, very good example of this. A soil-living organism, it infects the root of a soya plant or a legume plant, depending on which rhizobium it is. It colonizes that plant, and the plant then builds a penthouse. Why it spends so much money on giving the bacteria such a good place to live? These bacteria stay inside the plant and take atmospheric nitrogen, which we simply breathe in and breathe out and never use, and gives it to the plant in a form that the plant can produce grains of a very high protein content, and rest of its vegetation also high in protein. So after the grains have been harvested and the plant rest has been plowed into the soil, it can leave up to 150 kilograms of nitrogen behind it in the soil. Nitrogen that cannot be leached out by flooding, but is available for the second crop, which means your second crop may need a lot less or even no nitrogen fertilizer at all. Previously, I spoke to you about the problem of weed or weeds in the lands, and this is a second very large problem when you have massive monocropping. All the plants are genetically identical, and if they have a proclivity to a disease can totally wipe out a whole land. Often, when you see the damage done by a root pathogen, it is too late to do anything, and cures are often expensive and ineffective. If we were able to predict what was going to happen to a disease, we are proactive, and by studying the relationships, we can take preventative action, which is cheaper and a lot more effective. What you see here before you are the first of my very clear experiments, my excuses for running off to the glass house when you people want to do something else. Here are the results. Both these soils had been infected with a bacterium, hand mixed the pathogen into the soil. The top one did not receive any rhizobium. I simply mixed the pathogens in and planted the germinated seeds. The second one have the same amount of pathogen, 2 milligram, yeah, I think I measured 2 milligrams, but it got the correct rhizobium for soybeans. Fancy name, Bradyrhizobium japonicum. And that is the result. My plants are unfortunately not going to grain production, so I cannot show you the yield, but that should tell you there's a reason for the rhizobia. In order to do our preparations for our studies, to be prepared, we have to know our enemies. Hey, go away. Am I going the wrong way? Let's try that next. Oh, there we are. Pathogens are very well adapted to infect plants. Some of them literally hammer at the cell walls to get through. Others produce chemicals that can dissolve plant cell walls, giving them access to the next cell. They have cytoplasm dissolving toxins, very much like a spider that bites the insect, dissolves the inside, and then just suck the food out. And a very serious soil pathogen causes blocking of the vascular system, stopping the plant from moving water and nutrients around, and ultimately causing its death. Luckily for us, plants are also adapted to resist infection. If they didn't, there wouldn't be any more live plants around. One of the very first things a plant does is to thicken the cell walls, make it more difficult for the pathogen to enter. They produce toxins that dissolve the pathogenic cell walls. Sometimes the whole cell will commit suicide and thereby stop the pathogen from going on. And then the legumes have a fifth column. They're knights in golden armor, the rhizobia. What a rhizobium does, exactly the same way as a pathogen, it bores into the cells in the root. And the plant gets the message, I'm under attack. Now the rhizobia can cause no harm, but the plant activates all its weapons. This is called induced plant resistance, which differs from the genetically carried over resistance that a plant has. Now, when the plant has activated all these protections of it, it makes it almost impossible for a pathogen to infect. And this is the protection that the rhizobia gives the plant. And then, of course, the plant also gives the plant as much nitrogen as it needs. The nitrogen it needs to form its own plant material makes it stronger as well. Now, what affects soybean fitness? These are the variables that we had to gather together to build our model. First of all, the mass of the plant. The bigger the plant, the stronger it is, the more resistant it is, the more material it can lose without really carrying damage. Total leaf area, this is not part of our model as we look at below ground only, but this is the area that is in contact with the sunlight that creates the photosynthase. Total root area, which is important, the uptake of nutrients and water. The amount of nutrients in the soil, put there by the farmer or from the saprophytes breaking down organic material. And the amount and types of nutrient in root exudates. Now, plants actively and passively give off certain chemicals through their roots. Some of it has very specific functions, and some of it just contains natural good nutrients. Now, one of these nutrients that comes out attracts rhizobia. it's like a girl wearing a perfume. You walk past and you say, and that's exactly what the rhizobia do. They smell, they chemotaxically pick up this chemical, and they migrate towards the plant. Another very important factor that affects soybean fitness is the ability to form the nodules and maintain the rhizobia once they are in the root. Rhizobia, important, the amount of individuals in the soil and the fitness to infect, colonize, and induce nodule formulation. Therefore, farmers are told every year, inoculate your legume seed with the correct rhizobium to make sure that all these factors are active. Then the bad guys, the pathogens, they affect the plant by the amount that they have in the soil and the ability to infect and spread inside roots. Now, if you have the Hulk and he says the plants are strong, we're well away. There are many interactions that takes place in and around our plants. And when we do research, we need to take cognizance of all of them. Research results needs quantification. If you cannot measure, weigh, or count it, it has no value. And to understand an interaction, we need to be able to write an equation. On the root, there's a limited amount of infection sites shared between the bacteria and the pathogens. We give that the letter K. Now, if the rhizobium C occupies 99% of the root, only 1% of the root is available for pathogens. An equation is born. The very first, the very easiest one, and from here we start. Prof. Ulf Dickman said to us, please don't put down all your equations. The people are going to get bored and they're not going to understand them. But I don't always listen. So I would like you to present you with ours. Michael and I are extremely proud of them. I don't say we directly wrote them all, but we gave our supervisors the information they needed. Not only are we the only group where 2 students have 4 supervisors, we also have the smallest the smallest equation. No, go back. Previous, not next, silly. Previous. We have the shortest equation, and I'm almost sure that we also have the longest equation. This was quite a learning curve for Michael and myself. We have never worked with this stuff before. Now I come back to my research question. Can symbionts reduce incidence and severity of disease? If I look at the formula, K equals C plus I, if there's enough rhizobia, there'll be no disease. Sounds logical and easy, but there are 21 other equations, with various ones having effects on C and I. So in order to have a model, we have to integrate all these equations and account for all the variables. And then it'll no longer be a riddle to us. My same question again. Will this model help to teach us what we must do to get our plants disease-free? This was the baseline results. Now again, I use the excuse, Michael and I are new to models, but this is what you basically see in the size of the plant, the energy material in the exudates, the amount of pathogens in the soil, pathogen infection level, how fast does the pathogen infect the plant, rhizobia amounts in the soil. They drop so drastically each year because they need the plants to grow. And then the rate of rhizobium infection. In the second one, I manipulated, I don't know if that's the correct word, the nutrients, and I shoved it all off to the rhizobium, and you can see there's a slight difference in the graphs. Here I seriously stimulated the rate of infection, and you can see a greater difference in the graphs. And going on like that at this stage, the rhizobia has definitely vanquished the pathogens. Now, if this is probable, we'll still have to check. In summary, the rate of pathogen infection has slowed down the higher the rhizobia and the rate of the rhizobia infection was. Disease was averted and the plants were triumphant. For the last time I ask my question, does our model substantiate the hypothesis that symbionts reduce incidence and severity of root disease? According to us, it definitely does. But there's a lot of work we still have to do. We have to test all of these, every single one that has an applicability to, Michael and I have a combined model, but 2 different rows, so we have to make sure that each thing that applies to our own model. And then, of course, it will have to be tested in the field as well. I would like to, once this model runs clearly and gives us good results, the results we want, bring in the effect of the RR gene, which I had to drop because of the busyness, and then also look at the effect of the glyphosate herbicides, and eventually look at my arbuscule mycorrhiza.
Thank you very much.
Thank you.
Any questions, or should we discuss the 2 papers together? Are they close enough to each other, or? And then we have a joint discussion. Okay, so Michael.
Okay, so good morning again, ladies and gentlemen. My title is also a bit different from what it says on paper, but it should be similar to what I did in the midterm presentation. It is the influence of root exudates on rhizosphere interactions in sorghum cultivars and implications for plant development and incidence of root disease. And my talk will be complementing my colleague that did hers before me. So I will focus more on the development of our model because we are still in the finalizing steps of completing the model, and then we have some preliminary results which I have not put in the presentation, so I'm only focusing on the development of our model. Okay, so I'll start off with some background about my crop, which is not the soybeans, it's the sorghum. And then it is a very important cereal crop that is grown in Central America and South Asia. And it's the second most produced cereal crop in Africa. It has a very wide variety of use. It has use in grain food, in fodder, in biofuel, and has been used to produce alcoholic beverages. And it has been found to have a negative effect while it is grown in rotation with other crops, and this negative effect is being caused by an allelochemical that is produced in the roots of some sorghum species, and it has been found to be very effective in suppressing a large number of small seeded plants by influencing their photosynthetic abilities. Now, when I speak about allelochemicals or allelopathy, it is a chemical interaction that the plant expresses onto either the same kind of plant species or different plant species. It could also be a chemical interaction that the plant expresses onto microorganisms or even insects and larger animals that is surrounding the plant. And this can be either produced by certain plant plots, for example, roots that produce exudates, or can be present within the plants, for example, in their leaves, in their stems, in the fruits they produce. And allelochemicals have been recently been more studied because it can be used as a natural alternative for herbicides, which has been shown. But what I would, my PhD study focuses on is to see the secondary effects of these allelochemicals on microorganisms and other organisms that is surrounding the plant, because although we know it's like the chemical herbicides you use, you know it will definitely kill off the weeds and other plants that you do not want in the field, but you do not know if it has secondary environmental damage that it causes. And then this plant defense mechanism, we would like to see if it has a different secondary effect on the surrounding environment, microorganisms. And the objective of my part of the study is to determine the effect of sorghum genotypes, each with different potentials for producing these allelochemicals on soil saprophytes and soil pathogens, and to determine if this change in the soil saprophytes and soil pathogens have an ultimate effect on the yield of the same sorghum species, either in the same growing season or in the next crop that is grown after it. Now, this is the concept model that we shown in the previous presentation, and it shows an interaction between the sorghum plant, the root exudate that it produces, which is separated into two groups, and then how those root exudates has effect on the rhizosphere microorganisms, which have an interaction between themselves and has a feedback effect on the plant, and the plant will then have a trade-off and then decide which type of root exudate it will produce. And then this was our concept model for individual plants, and this is also as far as we have gotten in our model, our current model. We have the model, the equations that Annette have shown, and I will show again, is basically just focusing on the single plant interactions and the microorganisms next to the plant, and we are still trying to implement the spatial and then the spatial effects of it when it becomes a field, and I'll show it in a later slide. And these are the equations that Annette has shown previously. So I will be focusing on explaining how we derived and got to the model that we have right now. And so this is a basic flow chart of how our model works on a single plant basis. So the plant, I'll start off with the plant. The plant receives nutrients, absorbs nutrients from the soil, and then it divides into three different sections of plant investments. Now, the plant then invests this nutrient into either plant growth, into plant maintenance, and into the root exudate that it produces. Now, this root exudate then trades off into two different sections, into the energy-rich compounds and then the allelochemicals. The green and the red, the green shows the positive effects of the different variables on each other, and then the red represents the negative effects. So the allelochemical and the energy-rich compounds then influences the microorganisms that's in the soil. The saprophytes, which in my specific case divides into two different types, the saprophyte that can utilize allelochemicals as a additional food source, or the saprophytes is actually harmed by the allelochemical. The soil pathogen, which is harmed by the allelochemical. The energy-rich compounds then only benefits both of the saprophytes, and then there's also a competition effect of the saprophyte with the soil pathogen. The saprophyte then have a positive effect on the nutrients available for the plant. They produce additional nutrients that is that the plant can utilize, and then the soil pathogens then have a negative effect on this plant, which Annette has been showing in her previous presentation, the infection of the root material. So the increase infection of the pathogen will then decrease the ability of the plant to absorb the actual nutrients for itself to use as energy. And then I'll go into it a bit later. So we can basically divide it into a few different kind of interactions. The plant interaction, as I shown in the flow chart before, it will then determine the plant size and the plant yield. And as I've shown before, the plant divides the nutrients into the three investments: the plant growth rate, the plant products, and then the plant maintenance cost. And we separated the plant investments by determining their priority, and then also by determining the amount, which is the availability of the amount of nutrients, and then the absorption ability of the plant due to the presence of pathogen infection in the roots. Now we assigned the first priority to plant maintenance. Now if this is not met, the plant will decrease by its own plant size. In actual reality, it will the plant, if the maintenance cost is not paid, it will shed its leaves and then attempt to decrease its plant size to try and stay alive. And then ultimately, if it's not met up to a threshold level, the plant will ultimately die. The second priority then goes into the plant allelochemical production, which is a defense mechanism of the plant. The third priority is into the plant energy-rich compound production, and then the least priority into plant growth. So if there is not enough nutrients that the plant absorbs, the first thing that will happen would be the stunting of the plant growth. So the plant will stop growing. It will then decrease its plant energy-rich compound up to a minimum threshold, and then it will decrease the allelochemical production up to a threshold, and then ultimately the plant will decrease in size and will then die if the energy, the nutrients it takes up is not enough. And then also, as I mentioned before, the plant then has an infection level which only infects the root area by the specific soil pathogen that we have used in this model. Then the soil interactions, then we are talking about the amount of chemical compounds in the soil, and it's divided into the energy-rich compounds, which is produced by the plants and is only used by microorganisms within the soil, and then we have set it to only be consumed by saprophytes. And then the allelochemicals within the soil, which only interacts with the microorganisms, because we are talking about a field, a realistic field setup, agricultural field setup. So there will only be monocrops, or if we would like to bring in later a intercropping or rotational cropping, but that is in the later stage. But right now it will only affect the microorganisms in the soil, and it will have the effect of destroying the soil pathogens and several of the saprophytes. And then, but it also is a alternative food source for another saprophyte, and we have placed a half-life on the allelochemical, so it will break down and will not accumulate indefinitely. And then also in the soil is the nutrients available for the plant. It will be an amount which is added each season, which is a realistic amount, for example, the fertilizers that we apply to agricultural field, and then the nutrients produced by the saprophytes will be additional to this amount, and it will increase the ability of the plant to grow. And then the soil interactions, the amount of microorganisms within the soil. The saprophytes, in my specific case, are divided into the saprophytes that are able to use the allelochemicals, and then the ones that are actually harmed by the allelochemicals. And then we have implemented a death rate so that it will not, because previously we did not do that, and our test model had an indefinite growth and of the saprophytes, and then it was the results were very Okay, so we implemented a death rate which is dependent on the available food source of the saprophytes on the energy-rich compounds that is produced by the plants, and then the amount of pathogens have a size influence infectivity to the plant. So the more amount of pathogens within the soil, the higher the ability of the pathogen to infect the plant, and then the pathogen does not increase during the season, but only at the end of the season when the plant dies and then releases the infected parts back into the soil. And then we have also implemented a very low death rate for the soil pathogens, which is realistic, and it actually stretches across generations. That is the problem with the soil pathogens we have right now. They do not die within a agricultural year. They have a ability to live within the soil for 5 or 10 years without the presence of the plant. So they're very hard to get rid of. And then we're bringing in a time aspect. The time aspect we're bringing into the model is we're running it on a full year, and then a full year will consist out of a growing season and a fallow season. In my specific case, the sorghum plant, for an entire growing season, it will be approximately 6 months, and then we have a fallow season where there's no presence of the plant, but then the microbial interactions will still apply. And then we're trying to bring in, because right now our model is only at a single plant interaction stage, we're trying to bring in a special aspect where we will place the model into a agricultural field design within blocks of monoculture, and then we would like to see if there's a spread in the allelochemical contents and the saprophytes and the pathogens, and then hopefully we'll be able to get something like this, which will show the possible changes of spread of pathogens, which is represented in red, and then a development of saprophytes, which is represented in green, and see if there's an interaction between the saprophytes and the pathogens, and then see if there is we would like to be able to model the spread of the pathogens and see if we can put the pathogens under control with specific types of sorghum plants which produces different levels of allelochemicals. So the further developments would be, we would like to finalize the model for special interactions, and then we would like to produce results which shows the difference between genotypes under the sorghum plants under monoculture, or even we would like to show it under a rotational culturing technique in this field. Thank you.
Okay, thank you very much. So now we have questions both to Annette and Michael. I hope you still remember what she was saying. Yes.
Thanks very much. Thank you both. I work a lot on soils and below ground interactions and things like that. So I think it's a really fun area to explore. And we know there are millions of organisms in the soil and in the rhizosphere and in the whole rhizosphere area going out into the bulk soil. So your idea at the moment of having your 2 boxes of essentially good guys and bad guys, pathogens and saprophytes, or rhizobium, good, pathogen, bad. Okay, so that's a kind of a nice way to start. But do you think this approach could then be, taken further to say to what extent, if you're controlling and inoculating the rhizobium, would you win? Or if you're managing the pathogens in another way through, some pathogenicity through allergenic chemicals, could you win? So kind of going into an agent-based modeling, who's more important at any one time in the season?
I think we will definitely go into that further. As I said, Michael and I are brand new to modeling, and we really need to understand this one and exactly the information you need to put in, because if you put rubbish in, you'll get rubbish out. So we're starting very, very gently off with this. I definitely want to bring the arbuscule mycorrhiza in at some stage, and then more than one type of pathogen as well. But definitely to see as I manipulated it, there is an influence, and by inoculating, you make ensure that your area around the root is covered with a good bacteria, but definitely going further, yes.
Okay, any other questions? Yes, please.
Thank you for the presentations. I want to know, because you said further development or further work that you're going to do is testing the effect of herbicides, glyphosate. And my supervisor, one of my supervisors working with glyphosate, and his PhD, which lasts like 3 years, he was doing that. And I'm looking at you, you know, is it your final year?
Wow.
Second year now, and how long would that take for you to test the effect?
I'm unfortunately a part-time student, so it takes me double as long to do anything. But what I plan to do, and that experiment's actually running concurrently with this one now, where I also put the pathogens in, but only on the RR seed, obviously, and then challenge them with a herbicide and see if the presence of the herbicide does anything to weaken the plant towards attack by pathogens. And I am going to repeat it again next year and have to wait and see. Maybe the model will tell me before the time what's going to happen, but I will practically do it, yes.
Okay, any other questions? Either Michael or something? If not, then thank you again very much. So we have the last speaker before the tea break, Mr. Elvis Nokana.
Thank you very much, Program Director, and thank you very much to the last two presenters. I wish I could ask a question, but I know nothing about your subject. I will be talking about, actually my presentation is going to be in two parts, and I will be talking about climate change awareness in rural and township communities of Limpopo Province, but also the other part that you'll see later, it will be about the different types of social capital that exist, what are the different types of fiscal and social capital that exist between township and rural communities in the Limpopo Province in the north. So my supervisors are Dr. Nad and Dr. Vane. And just to get started, scientific evidence actually suggests that there's little evidence, research about climate change awareness in Limpopo Province, because when I was reading about this subject, there were very few articles, there were probably less than 5 on this subject, and these communities in the Limpopo Province, they are exposed to climatic risks, such as flooding and droughts, and also these climatic risks are exacerbated by non-climatic risks, such as poverty. However, people in the north are not aware of climatic risks and their linkages with non-climatic risks. So that NGOs, such as the eco-schools programs, are being implemented with schools in the north, and these are implemented by organizations such as the Foundation for Environment and Education, and the Foundation for Environment and Education is an international organization, but the local implementing partner in South Africa is the Wildlife and Environment Society of South Africa, and they have over 1,200 schools registered worldwide, and they are raising awareness with school learners on climate change issues, on water, on waste, on nature, on biodiversity, and on healthy living environment and other issues. So a bit about the study area. It is the Polokwane region in the Limpopo Province. Limpopo province is the northernmost province in South Africa. The Polokwane region is the capital, so it's the economic hub of the Limpopo province, and the population, 92% are Black African, and about 41% of the population is between the ages of 15 and 20 years, and youth unemployment is very high at a rate of 42%, and agricultural households comprise 42% of the study area, and households without income are about 13%, and there's a lot of inequality, as you can see from the Gini coefficient, also between the populations in that region. And we chose 2 study areas within the region, and this is the Ralema villages, where there's 14% unemployment and about 7.6% of the households that do not have income. There's a village community, but also chose a township community. And a township community in the Mankweng township, and where there's about 11% unemployed and about 25% without income. So it's very interesting to compare, to see that the rural village, about 7.6% households do not have income, but then in the township is much higher. But then also unemployment in the township is much lower, but in the village it's quite high. So it's interesting, but also because in the village there's a lot of subsistence agriculture, because village folks have access to land and township folks don't have access to land. Going on further, I found that there's lack of evidence on risk perceptions and forms of capital for climate adaptation in rural Limpopo province. But also, most studies that have focused in this area, they've exclusively focused on farmers. I decided to focus on other stakeholders. And so my research questions are, and from these research questions I got 2 sets of results. How does climate change awareness impact on major risk perception in rural and township communities in Limpopo province? And what types of fiscal and social capital exist in rural and township communities to cope with natural hazards? So these are the data collection methods, and You'll see we did focus groups. So in the villages, you can see there are 3 focus groups, but for longer periods, for longer minutes, for longer engagements. And in the township communities, we did also more focus groups. But if you checked in the terms of the allocation of the minutes, there's probably about 220 minutes. There's about 202 minutes, so they are similar in terms of the number that we engaged them. The reason we engaged the township longer, it was because it was near to the university where I was placed for my fieldwork, and the villages were quite far out. And so, we decided, we had 2 sets of focus group discussions for each. And in the first set of focus group discussions, we did not prompt the participants. So we just requested them to discuss any community issues of their concern. But in the second one, we exclusively asked them to talk about climate change, but we did not really explain what climate change was to them. And then we repeated the same process with the second focus group sessions. We implemented these tools. These tools are used mainly for participatory rural appraisal, but for participatory urban appraisal, but they're also used by climate adaptation tools that are developed by international development cooperation organizations. Sorry about that. They're also used by the World Bank, they're also used by the United Nations, they're used by Action Aid, they're used by the USAID, and all of those organizations. So this is the social network analysis scenarios tools, the future backward tool, the problem tree, the hazard impact and vulnerability and metrics. The critical variable in all of this, so we're comparing two groups. The critical variable, the main difference between the two is that this group, the Mankweng Township group, participated in that environmental awareness program that I was describing. But then the Ralema, the village group, did not participate in this environmental education program. So the data analysis, I use qualitative content analysis, which I described here. And I will describe it later when I show the results. Then I have the results on awareness. And the results on awareness, first, it shows that people are more concerned about short-term risks than they are concerned about long-term risks. The second finding is that the awareness about climate change impacts perception on major risks within a community. So if a community is more aware of climate change, it will be more aware of the risk that climate change will pose to that community. And again, awareness impacts on the perception of the linkages between this risk. And I'll go further, I will explain these results as I go on further. So this is the future backward tool. This is one of the tools that I used to solicit information from the participants. And then, so you can see these are, people are more concerned about short-term risk more than long-term risk. You can see here, so here they were not prompted, they just asked to speak about general community issues. This is the best future scenario in the community. So one of the, they spoke about they described decent living conditions, and the decent living conditions to them talks about community infrastructure, about good education, social security, employment, and in their current situation, they said they live in very poor living conditions, characterized by no employment opportunities, lack of basic services, such as roads and all of that. This is the village community, by the way. And when they had to imagine the worst future scenarios in the community, they described dysfunctional communities. So these are also the main categories, and this is the coding frame actually that I use. And then, so on climate change, and then, okay, just let me compare this village response to the township response. So the township response, they were more concerned about pollution and crime. So they were not speaking about lack of infrastructure, lack of basic services, because most of the time they do have these basic services, you know. And then, so it shows that people are more concerned about short-term risk. These are the short-term risks: pollution, no employment, whereas they are not that much concerned. You can see here, they did not provide loads of answers on, long-term risks such as that can be caused by climate change. I'm still going to come to this table later to explain more results, actually on this part. And the awareness about climate change impacts perception of current and future risks in the community. So this was one of the exercises they had to do. It was a very participatory exercise, a data collection method. And so coming back about, so this is the group that participated in the Eco Schools program. This is that participated in the environmental education program. So they spoke more on issues of climate change. They spoke more generally on issues of the environment, because they had environmental education, but that was coupled together with climate change. So they described their favorable conditions. They described the unfavorable conditions as heavy rainfall, heavy storms, ozone layer, aerosol emissions, because they'd been involved in a very intensive environmental education program. And they also describe other unfavorable conditions that they may experience in the future because of climate change. And then just to discuss the results further, awareness about climate change impacts perception on synergies between climate risk and non-climatic risk. So this is called a problem tree. It investigates the relationship between a problem and its causes and its impact. So I don't know if this is visible enough, but just to pick out one, I can pick out this one here, where they spoke about burning coal. So they are aware that the electricity that they get is from burning coal, and from coal power station that cause air pollution that can lead to ozone depletion, acid rain, and health problems in their communities. And then the second set of results is that the different form of capital exist in the village and township communities, and the forms of social capital and physical capital also differ. But also the task of risk sharing and resource pooling is fulfilled in rural communities, by community members in the rural areas, but mainly by private stakeholders such as insurance companies in the townships. And I'll just explain this. This is the social, I asked the participants just to draw, to indicate what are the important organizations in their community. And this arrow only goes, this is their school. This way, because this is what these organizations help their community with. And then this one is from the township community, where this community felt like they also do certain things. They also help each other within the community, because what this school does, it does a lot of environmental outreach program and lots of cleaning, fiscal cleaning the environment in their communities. But these are private stakeholders. APSA is a private bank. This is a school governing board. This is a hospital. This is a government department. So what do I mean by the forms of social and fiscal capital differ in the communities? what I mean is that in the communities, I think I explained it here. Let me start with fiscal capital first. What I mean is that fiscal capital, rural communities have more access to land for cultivation and livestock rearing, but then township communities have more access to public services, such as roads, water, hospitals, and so forth. And then in terms of social capital, so there are different types of social capitals in the rural and township communities. Well, in the rural communities, it's mostly done by women, it's mostly done by community members. I gave an example such as women savings groups. And then so the task of risk sharing and resource pooling in the villages is done by the community members. The example I'm giving here is the women savings group that will come together every month and save money. And then if there's a funeral or anything, they'll help each other. But in the township communities, most of this is substituted by private stakeholders. So private and public stakeholders. So you can see here that there's an Oprah Winfrey network that really funds that schools a lot in terms of other programs that they do. But they also have private banks also like this bank that helps them. There's also this Coca-Cola, for example. So this is a township community. And my conclusion, for this presentation, I conclude that this can be very good recommendation for policy-making processes on climate adaptation in South Africa in general. But also the important thing is that there needs to be future research which focus on household heads or breadwinners as major stakeholders, because one of the limitations I experienced in study was that I implemented other tools that I did not show here, that I'll show later in other papers. But the challenge that I faced was that, it was very difficult to implement a seasonal calendar with these learners because they are not breadwinners in their family. So you need to have breadwinners, you need to have farmers and all of those. But these are the people that I'm going to engage further in this research. And yeah, thank you for your time.
Thank you very much. Any questions?
Thanks, Elvis. It's a very interesting study. I just wanted to maybe make a comment. I think it would be important to triangulate your data because you just seem to have just the one side of the narrative. And also I didn't get a sense of your stakeholder mapping. So who did you talk to in the communities? It was just focus group discussions, but maybe key informal interviews. Like in the rural areas, your headmen, for instance, they play a huge part, maybe churches. I'm not sure if you spoke to those. Then just a question, how do you define unemployment in the rural areas? What's your definition?
I never thought about that, actually. But as I said, that just also to comment, I don't know if this will answer your question, but okay, the first I got that from the statistics, the unemployment. I got it from statistics of South Africa. But in my observation, as I said at the beginning of the slide, that it's very interesting to observe that there are fewer households without income in the villages. And let me just go and see what I said, just to let me not to contradict myself. I think I said it here. I said that in the villages, unemployment is this, in the townships, and I said fewer households without income and more households without income in the township. What I was trying to capture here is that I had discussions with this, tried to interpret this with my supervisor, but we came to a conclusion that because in the villages there's a lot of subsistence farming, like I said, and this might not, because this is at a very local level, it's a very village level, it might be captured here at this 42% of agricultural household, but I suspect these are mostly households in the villages because they have access to land, and the households in the townships don't have access to land. So this might mean that actually, even if unemployment might seem to be a bit high in the village, but it might be because that these villagers, they they live off the land, and that is not captured from the statistics that we have. So there might be less poverty in the township than there must be less poverty in the villages because of that element of subsistence farming, and then there might be more poverty in the township because in the townships people don't have access to such resources that people in the town in the villages have.
If you don't mind, just a follow-up comment. So I've worked quite a bit in Limpopo. What tends to happen is actually, if you look at the ages of residents of rural areas, they tend to be retired people. So the young people come into the cities to work, and maybe that's reflected in the township population. And then the retired people go back into the village, like vendor, and then they have income because they have, pensions. So that's also, I think if you maybe go deeper and sort of, you might begin to see those nuances.
Yeah. Okay. Yeah. Thank you very much. Yeah.
The first part of the question still was whether who were the group members? Were there more women than men, more older, young people? Maybe.
Yeah, no, there were young people. They were divided equally between ages, and then the young people divided equally between their gender and their academic achievement also, because I was very careful with choosing different academic achievements. And then the other thing is that the other group that was in the township participated in the environmental education program for quite a few years. And the village group never participated in that environmental program. Those were the major differences between the group.
Thank you. There was another.
And thank you for that, for the triangulation. That's very important. Thank you.
Yes.
Hi. Thank you very much. Just two things. There's been quite a lot of work done, actually, on adaptation in Limpopo. Sylvester Mpandele, lots of studies. Gina Ziervogel, I think you might know a lot of them, and even USAID. So you might find that quite interesting. But my real question is, do you think that when we go in and interview and do participatory work, and we start with climate change, because you had that in one of some of your groups, that's a concern, because most of the time people are dealing with variability, right? Do you, from your perceptions, do you think people are really thinking about climate change? Because that then goes to coping versus adaptation. So I just wondered if you could take us through that a little bit more.
Yeah, like I said, with these communities, and in the first instance, they are more concerned about their immediate livelihoods, in their communities. And if that livelihood is affected by climate variability, and then they will think about it, but and I will argue in this paper from the evidence that I got that people are more concerned about livelihoods. And then, in terms of climate change and climate variability, I guess I don't really want to be defensive, but I guess I never thought about it in terms of phrasing the question, because when I phrased the question is because when I looked at climate adaptation tools that, of course, about that these NGOs have and they implement in these communities, they use different types of languages to describe different types of things. But then also one of the major challenges is that, and when you go into a community with this tool, you start speaking to the local people, and what you discover, I read all the tools and I went through all of them. But then what you discover is that one of the first things that they prescribe and that they should prescribe is that you should not tell the community you should not tell community what they want to hear or what you want them to tell you. You should just go with a clean head and then ask them. That's why in the first instance, I did not prompt them to talk about it. I just said they should discuss just general community issues, and this is what came out. But the second instance, of course, I spoke about climate change, and for a lack of a better word, I don't know what word I could have used, and that's why I just put it to them and said climate change, and hence that's why the group that participated in environmental education came out more and spoke more about it. They've done other environmental issues that were not related to climate change, and they spoke about them in there. But yeah, I think I am going to take that up. And Mpandeni, I read Mpandeni, and just that I did not quote him. Yeah.
Just
Thank you very much.
Thank you. Is there any other question? Well, we are already into tea time, break time, so I thank you again very much.
Oh, thank you.
And we'll see each other at 11:20 for another final 2 presentations. Thank you.